Liking this video will help this channel to grow. So please go ahead and give this video a like.
In section 1 of our lesson on similarity, we focused on similar lengths. In this video, we're focused on similar areas. Guys, don't forget to share this video and keep that momentum going. So, let's start with looking at scale factors. Now, let's consider the following. If x is the scale factor for length, the area scale factor would then be x squared. Remember, area is measured in squared units. So therefore, if we're going to find the area scale factor, we must first of all find the linear scale factor, and then we will square it. As I said before, area is measured in squared units. So if you hadn't watched the video that was done on linear scale factors, I suggest that you go and watch that one, so then you'll be able to make that smooth transition from the linear scale factor to the area scale factor. Now, let's consider these two shapes here. What is the area scale factors that link them? Now, in the previous video, we talked about the linear scale factor of these identical shapes. So we looked at the fact that if we count the squares along, this bit is 2, and on the blue shape, it's 1, 2, 3, 4. So the linear scale factor that linked them, LSF, linear scale factor, all we needed to do was to do 4 divided by 2, and that's equal to 2. Now, for the area scale factor, which we can write as ASF, all we would need to do is to square that linear. So 2 squared is 2 times 2, and that's equal to 4. So we're saying then that shape B, the area of shape B is 4 times larger than the area of shape A. Amazing. So that's all we need to do. Find the linear, then square it to get our area scale factor. So let's calculate the area scale factor of the following. So find the area scale factor that links shape A to shape B, and then for the other one, we're going to find the scale factor that also links A to B. However, I've put the larger shape first. So let's go. So we are given 6 and 18, which are the matching pairs. So first of all, we need to find the linear scale factor. So LSF. So we need to do 18 divided by 6. So 18 divided by 6 is 3. So remember, we need to now square this for the area scale factor. So ASF would then be equal to 3 squared, which is equal to 3 times 3 is equal to 9. So therefore, the area of shape B would be 9 times larger than the area of shape A. So next question, similar thing that we need to do. But what I'm going to do for this one is to work the other way around to say, what is the area scale factor from B to A? So what we would need to do here, so I'm just going to change the question and swap them around. Find the scale factor that links shape B to shape A instead, just to give you that experience as well. So what we need to do is to find the linear scale factor by doing 15 divided by 30. So we can write that fractionally as 15/30th, and then that will be equal to 15 into itself goes once, and into 30 goes 2. So that's the linear scale factor. So let me just write LSF, and then what we need to do now is to do ASF would then be equal to 1/2 squared, which indicates 1/2 multiplied by 1/2. So 1 times 1 is 1, and 2 times 2 is 4. So to get from B to A, we are going to be making it smaller. To get from A to B, it's going to be smaller. So therefore, the scale factor would be smaller. It's going to be a fractional scale factor. Now, I changed the letters here, but they were okay. So I'm just going to scrap that. So it's going to be from A to B, we're getting smaller. So this working out is correct. The letters were originally okay. So it's from A to B because we're getting smaller. So it would be a quarter for that scale factor. Okay, now we are doing an actual question here. So it's a calculating similar areas using scale factors again. So quadrilateral A and B are similar. So the area of quadrilateral A is 32 centimeters squared, and we're asked to work out the area of quadrilateral B. And that is for 3 marks. So again, first of all, I know I must find my linear scale factor. So the linear scale factor, we can use 16 and 18 and 8, which is the matching side. So 16 divided by 8 is 2. So remember, for the area scale factor, what we need to do is to square that. So we're going to do 2 squared, and 2 times 2 is 4. So we're saying that the area of shape B will be 4 times larger than the area of shape A. So area B is equal to the area of A, which is 32, and we need to multiply that by the area scale factor, which is 4. I'm just going to quickly put that in my calculator. So 32 times by 4, 32 times 4 is 128. And remember, unit for area is squared. So it's 128 centimeters squared. Absolutely brilliant. You can see a very easy 3 marker there. So we go to our next question. So shown are 2 logos that are mathematically similar. We're given the area of the smaller logo to be 20 centimeters squared and the side is 4 centimeters. We only know the length of the larger one, which is 20 centimeters. The area of the smaller logo is 20 centimeters squared. Find the area of the larger logo. So again, I need to find my linear scale factor. So matching sides are 20 and 4. So if I do 20 divided by 4, the answer is 5. So the linear scale factor is 5. Now I'm going to use that to find my area scale factor. So that's equal to 5 squared. So 5 times 5 is 25. So the area of the larger logo will be 25 times as much as the smaller one. So larger area is equal to, we've got 20, and we need to multiply that by 25, which is our area scale factor. So 25 times by 2, times by 2 is 50, and then we're timesing by 20, so that's going to be 500. So the answer is 500 centimeters squared. So this could come on a non-calculator paper, so you can just use multiplication by 2, and then it's by 20, 0 at the end. We just simply need to add a 0 as well. So that gets us to 500 centimeters squared. Do not forget to put the square unit. Area is measured in square units. So we go to our next question. So this time around, we're told that we've got, again, 2 mathematically similar parallelograms. This time we're given the area of A, the area of B. We're given the length of one side of A, but this time we're asked to find the missing length of the larger one, B. So this time we have to work from the area scale factor to the linear scale factor, since we are finding the missing length. So what we can do here, area scale factor would be the 2 areas divided by each other. So I need to do 45 divided by 5. So the area scale factor is 9. Now I need to find the linear scale factor. So to find the linear scale factor, I have to now find the square root of 9. So square root of 9 is 3, since 3 times 3 gives me 9. So now that I've got the linear scale factor, I can go ahead and find out the value of x. So I know that x would be equal to the original number, which is 2 here on shape A, multiplied by the linear scale factor, which is 3. So therefore, x will be equal to 2 times 3, which is 6. So hence 6 centimeters. So once we know the two areas, if we divide them, we're finding the area scale factor. Now we have to do the opposite of squaring to go from the area to the linear. So we got to do the square root. When we square root, we now have the linear scale factor. All we need to do is to apply the same principle as we did when we were finding similar lengths, by just multiplying original by the linear scale factor if we're going from small to large. However, if we were going from the large shape to the small shape, we would have divided by the scale factor. Very important to note there. Beautiful. So now we go to another question, which is actually the final question. So we're told here that solid M and N are similar. We're given that the height of M to the height of N is 2 to 3. So let's write that up before we read anything else. So we've got M to N, and we're going to put 2 to 3. So because it's the height, it's a linear scale factor. Here, the ratio is in linear components. Now, we're told that the surface area of N is 360 centimeters squared. We want to find the surface area of M. So, first of all, what we have to do is to find the square of the two ratios so that we can get the ratio of the area. So we need to do 2 squared to 3 squared. So that means for the area, the ratio of the areas would then be 4 to 9. So we're told that the surface area of N is 360 centimeters squared. So we're going to put that underneath this ratio, 360. So we can then go ahead and find out what is 1 part by dividing 360 divided by 9. So 36 divided by 9 is 4. So 360 divided by 9 is 40. So to find the surface area of M, let's just write that down. Surface area of M is equal to, I'm going to multiply my ratio part times by 1 part. So I need to do 4 times by 40. So therefore, 4 times 4 is 16. So 4 times 40 is 160, and the unit is centimeters squared. It's just as simple as that. So once you know how to find your linear, you can find your area by squaring your linear. If you know your area, you need to do the reciprocal or the inverse, which is going to do the square root. So it's actually the inverse I wanted to say. So you do the square root of that. So now it's time for our key takeaways. So remember, if we've got x as our linear scale factor, then all we need to do is to square that to get our area scale factor. Remember, to get the area scale factor, we must first find the linear scale factor and then square this, because area is measured in squared units. It's really that simple. Of course, there will be other questions where you have to apply other ratio skills and maybe some algebraic questions as well. It could get more complex, but important thing here is to make sure that you have got the basic foundation as well. And remember, I've said before that we put other questions that we haven't done in the lesson on our TikTok page as well, so you can get other practice. And also I will put a few more practice questions on finding area scale factor and finding similar areas as well in the description of the video, and also the answers will be recorded. Now, if you haven't liked the video yet, guys, remember how important it is for you to do so to help me to build this channel. And also make sure that you share, hit the notification bell if you haven't yet done so, and look forward for the next one, which is going to now be on volume. So we're going to find volume scale factor and apply that to similar volumes as well. And thank you so much for watching.